In this video, we're going to look at the first day core problems from lesson 1.1.2 in the CPM Algebra 2 course. This is problem 110. So in this problem, as a group, you're going to be assigned one of these 8 functions, and you're going to learn about and explore what these functions look like. The main goal is to start to learn how to use a graphing calculator or the Desmos website or app to start to understand their capabilities. So if you use a graphing calculator, this would be the one I would use, a TI-83 CE+. This is a screenshot of a premium CE. They're really highly functional calculators, and they work very well. They are also able to be used on, college entrance exams, such as the ACT and the SAT. Desmos also is very useful and something every Algebra 2 student should learn how to use. In the book, there will be e-tools linking to certain problems that will help you explore this. In the description of this video, I will provide the link to that e-tool should you choose to want to use it. So what you're going to do is, with your team, you're going to describe this in as much detail as possible. We're going to generate a table and a complete graph of this function. And then it gives us our 4 points of what it means to graph something, which was on the homework assignment from lesson 111. It really wants you to work together to look at different aspects of this graph and how to use the calculators. So if you are working on this with the tape partner group, keep your calculators or computers or phones with Desmos on it in the middle so everyone can see your work. This all culminates into you completing a presentation, a poster of what you learn about this function. Okay, so for this example, I'm going to use this function, the 6th function, and we're going to use it to just make a table, make a graph of that thing, and then we're going to describe some things about that function in this space here. Okay, so now what we have is we have a square root function. So when I have square root functions, I want to select input values that will give me what is known as a perfect square value underneath the root. So perfect squares are something that if you don't know them already, you should start to memorize them. I'm going to write at the very bottom of the screen a list of those perfect squares. They are 0, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196. Those are the first 14. Now they occur because when you square a number, these are what you get, starting with 0. And so, because we do not like to have negative numbers under square roots, these are the values that we want the insides to equal. And so the first thing I'm going to look at is x plus 9. And I want to say, what value of x makes x plus 9 equal 0? That'll be my first entrant. So I know when I make x negative 9 plus 9 is 0. So we're going to put negative 9 in for my first x value. Then either in my calculator or mentally, let's calculate this value. Negative 9 plus 9 is 0. Square root is 0, 0. Negative 3 times 0, 0. 0 plus 4 is 4. So the point negative 9, 4 is on this graph. So we're going to plot that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 3, 4. So that point is on the graph. Now I'm going to make it equal 1. So when x is negative 8, I get negative 1. So I'm going to put negative 8 in there and let's calculate it. Negative 8 plus 9 is 1. The square root of 1 is 1. Negative 3 times 1 is negative 3. Negative 3 plus 4 is 1. So negative 8, 1, 2, 3, 4, 5, 6, 7, 8 gives me positive 1. I'm going to keep doing this till I can't plot any more points. So let's talk about 4. So what number makes x plus 9 4? Well, that'd be negative 5. So here we go. Negative 5 plus 9 is 4. Square root of 4 is 2. Negative 2 times 4 is negative 6. Negative 6 plus 4 is negative 2. So negative 5 gives me negative 2. Now to get 9, that's going to give me 0. And so, so to get 9, I need 0. So 9 square root of 9 is 0. Whoops. So let's try it again. Square root of 9 is 3. Negative 3 times 3 is negative 9. Negative 9 plus 4 is negative 5. So 0, negative 5 is on here. Now 16, what plus 9 is 16? Well, it's 7. So the square root of 16 is 4. Negative 3 times 4 is negative 12. Negative 12 plus 4 is negative 8. So 7 gives me 6, 7, 8. And it's clearly 25 will be too big, but I could keep putting values in. I'm going to connect these dots. So it seems like it goes from here to here. We always put the arrow out. Again, I missed the dots. That's okay. I'm going to make them bigger. Now I could put more if I want. Okay, so these graphs look like this. Now plot more points if you would like. That's okay. But normally 5 or so points is good enough. So now what it wants me to do is describe some key points. So key points are points that we want to describe because they give me key characteristics of the graph, okay? Every kind of graph has one. So the first set of key points is the intercepts. So let's talk about the y-intercept and the x-intercept. Whenever we talk about key points, we label their points. So y-intercepts occur when x is 0, so I have that value here. So y-intercept is at 0, negative 5. So on my graphs, I always label those intercepts. Okay. Now the x-intercept is when y equals 0. I don't have that here, so what I could do, and I'm going to do this up here in the graph, is we're going to set the equation equal to 0, and we're going to actually solve for what value of x gives me 0 out. So to do that, I'm going to subtract 4 over, divide by 3, which makes that positive 4/3. Now to get rid of square roots, I square both sides. So I get 4 squared is 16, 3 squared is 9. Then I'm going to subtract 9, but 9, again, I need common denominators. So 9 is really 81 ninths. So I'm going to subtract 81 ninths from 16. And so 16 minus 81 is negative 65 over 9. So that's my x-intercept. Would be at negative 65 over 9, 0. So that would be this point here. So I'm going to label that point. Okay, so we can always find intercepts. If we can't see them right off the bat on a table or a graph, we can solve for them. Now, another kind of key point is where graphs tend to start or stop. Well, this graph seems to emanate or start from that point there. So we're going to call that the starting point. And so that was the first point I graphed. That's the point negative 9, 4. And so we want to name that point. Now these graphs can end. It can actually come from the left-hand side and seem to end. So we call that a starting or ending point depending on the orientation of these graphs. Another key point is where graphs seem to turn, where they have a high or a low point. Now, -9/4 would be a high point because that's the greatest y value on the graph. However, it doesn't turn there, so there's no other key points here we would talk about. Okay. Other things we would talk about is the domain and the range. So in the last lesson, in the math notes, was the conversation about what domain and range were. So the domain is the set of all possible input values I can plug into the rule. Now, graphically, what you do is you look left to right to talk about domains and ranges, okay? So this graph does not go left and right forever, but it does go right forever, which means it has the lowest x value point. And that lowest point, put this in orange, is -9. So it seems like the graph, since it goes right from there, would be every x value greater than -9, since the graph goes right, and x's gain values as you go right on the graph. But it also includes 9 because that point is included on the graph. So we say the domain would be all of x values that are greater than -9, including it, so greater than or equal to 9. Now the range is all the set of possible outputs. So what kind of values can I get out graphically, or what kind of y values graphically exist on the graph, or what are my possible outputs I can get algebraically. So graphically, I look vertically up and down. I ask myself, does this graph go up and down forever? Well, it clearly does not go up forever, but it does go down forever, which makes positive 4, sorry, I'll circle on orange and green, would be the highest y value. So since the graph goes down, it seems clear that all the y values are less than 4. So we say the range is every y value less than 4, but since 4 is included, we put an equal to sign. And those are the things we want to be able to describe about graphs. We want to be able to make a table of a function. We want to be able to graph the graph of that function. We want to be able to list key points, which are always intercepts, points where the graphs start or stop or turn. We want to label those points on the graph, and then we also want to describe the domain and range of these graphs. Okay? The domain and range is something we will constantly work on in this course and get better and better at. Okay, so the math notes for this lesson, I'll do a linear equation, so I'm going to highlight a few important things. So the first thing is the definition of a linear function. So a linear function, linear function is an equation that forms a line when it is graphed. My highlighting is very poor today. Let me try it again. I'm disappointed in that. So I'm going to highlight this. Want to know this definition. Now there are different forms equations can take, so part of your job is to quickly identify those. The first is standard form, and that's an equation written in ax plus by equals c form. The key is that the a and the x are on this, the x and y on the same side, and a, b, and c are all integers, no fractions or decimals. And the next thing is the most common one where we should know by now is the slope-intercept form. It's an equation in mx plus b form. The idea is that you want to be able to quickly identify, hey, this looks like this form, so therefore I should expect my graph to be a line. Okay, those are the two most common forms that you'll see in this course of a line. There is one more. That's something we'll talk about more when we get to chapter 2. Now, another thing is the slope is known as the growth factor. That idea of a growth factor is important, especially with exponential functions later. And we want to be able to identify the y-intercept. Okay. So it would be worth it to review this concept. There's a lot of great videos on YouTube that talk about linear equations if you need more of a refresher of this. But at this point, Algebra 2, it's expected that you know this, that you are able to graph lines, that you're able to quickly identify what form it's in, and be able to talk about the intercepts and the slope. So if you struggle with that, take some time and go review this concept, okay? So that is it for day 1 of this lesson. There won't be a video on day 2 since you're just going to take your own function and kind of recreate what we did on this slide, on the previous slide I did here, on a poster board for your classmates and your teacher. So, hope this helped. If you found this useful, this video was insightful, please consider liking the video and subscribing to my channel. I'd appreciate it.